Hi guys, welcome to Crackgate Online. Here we are going to start a new chapter on tractor hydraulics. In this chapter, we will try to cover the basic hydraulic system used in tractors, its components, previous year questions on hydraulics, and your queries. This is something about myself. So the content is the need, then the application, then little bit fundamentals, and the main topic basic hydraulic circuit. Now, first of all, we need to understand the need of hydraulic system. Say you have a load here, W, it is 500 kilo at this place, and you have to move it here. It is little bit height, on little bit height. So, what are the best possibilities? You can do it by mechanical linkages, or you can do it by cam mechanism, or you can pull it, but all those system will be very heavy and it will be very difficult to operate, and it may be time consuming also. But with hydraulics you just have to add one hydraulic cylinder. You have to fit it here. You just take the hoses or the fluid connection. You make one control mechanism here. You add pump. You make one control mechanism, and with lever or with knob or with electrical switch you can operate it very easily. So your effort will be very much less, and space will be, that will also be very much compact, and your system will be very much in your control. And one another application is the transmission of power, the hydrostatic transmission. There, with the help of pump and motor, you can easily transmit power with n number of speed ratios. That will be covered in hydrostatic transmission chapter. Now we'll see some applications of mobile hydraulics. Power steering system, hydraulic braking system, weight control system, or you can say transmission controls. Weight control system means AMT or any dual clutch control system, or power shift transmission. So these three are applicable both in automobile and tractors. The next one is tractor hitch control system and auxiliary applications like front end loader, dozer, or tipping trailer, etc. etc. Now we'll see fundamentals of hydraulics. The pressure exerted anywhere in a confined and incompressible fluid is transmitted equally in all directions throughout the fluid, such that the pressure ratio, the initial pressure difference, remains same. So here two words are very much important. One is confined and another word is incompressible. So the system should be confined or the volume should be restricted. If the volume is not restricted, if it is connected anywhere to outside or the surroundings, so by that place the pressure will get leaked and the whole system pressure will become zero or the equal to the surrounding pressure. And the next one is incompressible. The fluid should be non-compressible, because if fluid is compressible then the volume will decrease and the pressure effect won't be reflected in that system. Correct? Now we'll see this example. Here you can see three pressure gauges are fitted at different height. So at P1 it is 1 at initial, and P2 3, and at P3 it is 5. So in this system, as per this fundamental, in this system if we add 5 unit, then P1 will become 6, P2 will become 8, and P3 will become 10. So as per this fundamental, you can see the initial difference. So initial, if you can see the difference between P1 and P2, that is same. P2 and P3, or P1 and P3, that is same. Although by adding this 5 unit, that can be any place in this system, here or here or here, anywhere. This is getting reflected in all the pressure gauges, but the initial difference is same. Now we'll make one hydraulic circuit. This is the main topic. Here you can understand how to build up a hydraulic circuit. So it is a typical hydraulic circuit. So the output device of this is the hydraulic cylinder or hydraulic actuator. That is the main output device in any hydraulic system. So we have added one hydraulic actuator. At this end, we have to overcome one force, say F. So this is our output requirement. So to overcome this force, we need to generate this equal and opposite force at this end of this cylinder or the actuator. So in fluid control system, we can generate this force in terms of pressure, and the pressure into the area of this piston will be the force. So how this pressure will be generated? So for that, to getting this pressure, we need to give flow of oil. So who will give the flow of oil? So for that, we have to add one pump in this system. So the pump will give the flow of oil to the actuator. So what we have added? We have added one hydraulic cylinder and one pump. Now how this pump will run? To run this pump, we need to add one motor in this system. Motor is added. Now we need one sump. So from where this pump will suck the oil. So we have added one reservoir. Now this pump is running by this motor. It is getting the flow of oil, the oil from the reservoir, and it is getting transmitted to the hydraulic actuator. Now the oil is coming here and it is pushing this piston, and this force is getting overcome, and when the force will get overcome, this piston will come at the end. Now when it will touch at the end, we have another requirement that it has to go back to the initial position. So for taking it to the initial position, now I have to give flow at this end of the cylinder. So how will give flow at the another end? For that we have to add one directional control valve. This direction control valve will change the direction of fluid, and it will pass the fluid from here to this point, this line. So another requirement is that directional control valve. Now to set the pressure in this system, so there won't be any damage in this overall system, we have to add one relief valve for the safety purpose of this system, or set the maximum pressure of this system. So we have added one relief valve in this circuit. So if the maximum pressure will reach, that time the relief valve will blow off and the flow will come via this way. So relief valve is also added. So apart from this, we can add one check valve here. So there won't be any back pressure effect on this pump. This is a safety purpose. This is also another safety valve in this system. And one throttle valve also can add it, so that we can control the flow in this direction. So that flow, by controlling this flow, the speed of this cylinder will be controlled. So this is a typical hydraulic circuit. So for making any hydraulic system, you have to add minimum one pump, one reservoir, one hydraulic actuator, one relief valve, and one direction control valve. This check valve and the throttle valve are optional. Here you can see the construction. This is the pump. This is the check valve. This is the direction control valve. This one is the throttle valve. This is a adjustable relief valve, and this one is the double acting hydraulic cylinder or the actuator. So with this, I am going to close my presentation, first presentation. Thank you very much for listening. Please subscribe us, like and share, and this is to be continued. And please leave your comment on this video and your requirement, so that I can make video as per your requirement. Okay, thank you.